we have, how many valence electrons does barium have? And what energy level do they occupy? So barium, valence, and what energy level? So with that being said, we're going to look at the periodic table, okay? And we first have to find barium. Barium is right here, okay? It is on the sixth, sorry, I'm blanking out. Sixth row, okay? And it's on the second column. So barium, this case is on the second column, would have 2 valence electrons. And at what energy level? Okay, it's actually answered by the row it's in. It's going to be in the energy level 6, well, the 6th energy level. So for these type of questions, by finding out the row it's in and the column it's in, you should be able to theoretically find how many valence electrons and what energy level it's in. The tricky part is if you ever ask this for transition metals, because it's not always face value. But for columns 1, 2, and 13 through 18, it's relatively straightforward how many valence electrons they have and what energy level they're at. So just to review, the valence electrons is found by the column they're in, and the energy level is found by the row that they're in. Okay? So let's see what we have for choices. 1 valence electron in the 6s state? No. 2 valence electrons in the 6s state? Yes. No valence electrons? Definitely a no. So the answer here is B. B best describes barium. Well, that was a nice alliteration. And so for this one, they just went ahead to do the whole electron configuration. And they do end up with 6s2, which is what we can see actually by just doing the row and columns. And as you can see here, therefore the answer is B, 2 valence electrons in the 6s state. And this is what I mean in regards to, I guess, getting that extra help for transition metals. For transition metals, if you're not sure, draw the electron configuration and try to piece it from there, because they do actually help a lot trying to figure out what the valence electrons at least is going to be. Because the energy level is relatively straightforward, because it'll still be in a certain row, but the actual electrons, that's when you would involve the electron configuration, just to really see, okay, how many electrons are actually on the outermost shell. And now for question